Okay, so hi everyone. Thanks for joining us for question 4. I think this is. So this time it's Sean's turn to answer the question for us. So this time we're gonna ask a sorting question, sort of.
Okay,
And the question is,
let me share my screen really quick.
okay, and I need to pull up the question. So sorry everyone. Um, so this is actually from the book.
Mm-hmm.
Uh, so the task is write a method to sort an array of strings so that all the anagrams are next to each other.
All the anagrams are next to each other.
Yep. And an anagram is a string uh, where if you read it, so where you can read it backwards or forwards, and it'll still be the same.
Is that a palindrome as well?
Uh,
Oh, you mean anagram is like a
oh,
sentence
wait, sorry,
palindrome?
my bad. No. That is a palindrome. Gosh.
Okay.
Uh, an anagram is something that is made of the same letters. So let's say
Oh, okay.
ABC, CAB, BCA. Those are anagrams.
You can see my screen, right?
Uh, I haven't looked yet.
Okay.
Let's see. Yeah, yeah. I'm looking for my solution. So,
Got it.
but yeah.
Let's do B, C, B, A. Okay, so you have an array of strings.
Yep.
Um, and you want to determine if each uh, you want to sort an array of strings such that anagrams are next to each other.
Yeah. So you have an array of strings, and you want to yeah. So the array is unsorted, and when it's
Mm-hmm.
sorted, all of the anagrams will be next to each other.
Okay, so by sort, we only care about anagrams being next to each other. Do we care
Yep.
about it, the whole, everything in the array being in order as well, or no?
No.
Okay, so it's like
So
a.
as long as the anagrams are together, then it's fine.
Okay, so it's like a special sort. Okay, so I'm gonna write an example. That's my. Let's say I have AB,
Mm-hmm.
ABC, uh, BA, A, and CBA. So when this is sorted, this is my array. When this is sorted, I'll yield something like AB, BA,
Yep.
ABC, CBA, and then just A by itself.
Yeah, that works.
Okay, so this is a
That's valid.
valid. Okay. All right. So I know I will have to, and these are ASCII characters, right? Or
So I
can they
don't
be?
think it. Uh,
Doesn't make a difference.
I don't think it makes a difference. But let's say, for simplicity's sake, let's say it's just they're just
Just
alphabets,
okay. So
and
just
you can
character.
also say it's just characters, yeah, and you can also say they're all in lowercase for all of these if it makes it easier.
Okay. Are there null values in this string?
Um, no, let's say there aren't.
Okay. And same with white space, right? Or I guess we can treat it as another character.
Yeah, yeah.
That's fine.
Let's say there aren't any. Let's say you can ignore white space. Or let's just say there aren't any white spaces.
Okay. Hopefully my handwriting will get better at the end of this. All right.
Oh, you're using a mouse, right?
No, I'm using my tablet. I
Oh,
just
okay.
didn't plug it in last session.
Good.
All right. So a brute force solution that I can
Mhm.
think of is you go through each array or each member in the array,
Uh-huh.
say AB, and for each AB you do another loop checking every other member after it. So
Okay.
AB is ABC, a anagram of CBA. Oh, sorry, of AB. It's not.
Mhm.
Um, is BA an anagram? Yes.
Mhm.
And then you stick that in the index after it.
Okay.
So this will turn into AB and then BA, and then this will swap since it detects it.
Mhm.
So that's ABC, A, and CBA. And then our index, our like kind of target check index will jump
Mhm.
to here.
Yeah.
So now it's saying, oh, now I'm looking at BA. We can guarantee this jump because AB and BA we know already are anagrams.
Okay.
Um, are the members in the array, can they be unique? I guess it doesn't really matter.
Unique as in,
Unique
can we have
strings?
AB and then AB?
Yes.
Yeah. Well, they're not guaranteed to be unique.
So it
So
can happen.
you could have AB, 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 ABC.
Okay.
Okay, yeah. So
Okay, so once it's at BA, it will look again at the next element. Does it have to? It doesn't. I think we visited. Well, anyways, for brute force we can. It'll look at A, B, C. Nope. A, nope. C, B, A. Nope. And once it's reached the end of the array,
yeah.
we know everything after this AB will have anagrams next to it. Um, and then,
Or yep.
so we can jump to, I guess we can jump to this one. Keeping track our last visited was
Yep.
this. And then this will do the same. A, nope. CBA, yes. And no swap.
Mhm.
And then detect end. This, the target will jump from CBA to A, and
Yep.
then it'll know it's the end, so it's done. Um, an algorithm like that takes
Well, think of it this way: if it was
okay.
just an array of numbers, And if you did that, how long would what's the runtime for that? Simplify it.
It's kind of
So
like a bubble sort, right? It's like
yep.
one, do like, I guess like if I simplify this, it'd be like 1, 2, 1, 3, 1.
Yep.
It's taking 2. Yeah, the worst case for this is like if things are at the end, there's like 2 elements in the end matching, it has to go through the whole list again. Doesn't?
Wait, why?
Hmm.
Sorry, you said if what? I didn't catch that.
Okay, for I think the brute force here, depending on how you implement it, it is n squared, but if you optimize and you keep the trackers updated, you can do so on n time. So aka once you swap, you remembered you've visited everything else before in the middle of the swap, between the 2 swaps. Does that make sense?
It's a bit abstract, but
Okay. So
I think I know what you're trying to say.
yeah. So let's say if CBA swaps with ABC, we already know CBA is greater than A, so we don't have to. Or rather, if there are elements between A and CBA,
Yeah.
but these swap because ABC needs to pair with CBA, we already know we visited the elements here inside. And then we can kind of keep going. So, is it, but for each element, we need to iterate to the end and have a new target. So, yeah, so you're right, it's O n squared,
Yep.
worst case, for time, or time.
And okay, so what about comparing the strings to see if they're anagrams?
Yep. I am thinking of doing it in
Here,
an
just
array of strings. Yeah, so
okay. Sorry, don't go on. So
yeah, so let me change my color. This will be comparing. So there's essentially 2 problems. Kind of one is actually traversing the array and then swapping it. The other sub-problem, is actually finding out if 2 strings are anagrams.
right.
Okay, so comparing string for anagram. One way I can think of doing it is sticking the character indexes into a array.
Okay.
So our assumption has we only use characters, lower characters, no white space and no nulls. So we can have a constant size array like character array with size 26. So for each character in a word, I tick sorry, not a car. Just do bool, like a boolean. All initialize to false. So for A, our index would be 0, and B, our index would be 1, and we set 0 and 1 to true. once we look at BA, it will tick 1 and then 0 here. And once we've finished the ticking, we go through this every single character or every single index in the bool array to check for
okay. So
counts.
I'm gonna add something. So what if?
Yeah.
So you have.
Here you go.
I'm gonna say these strings are not representative of the entire like. It's not a. It is sort of a special case. What you're working with.
Okay.
So the strings.
Yep. So, yeah, I do think I need to
If,
count the character
what if
itself.
what if there's a string ABB
Right.
instead of
Right.
just A?
Yeah. Um. Yeah. So I've changed the array into an int array, and it would
Yep.
just increment the number of times it sees a letter. So for ABB, uh, index 0, or let's do like index of 0 would be
Yep.
1, and then index of 1, which is B, would be 2. And it will loop through everything. So we need to keep track of the number of times we see a character. Such a comparison is O of O of n for the number of n for number of characters we need to look at. Since our integer array is of a constant size, we essentially get this for constant time for free.
And this n, is that the length of both strings or?
Yeah, let's call this m.
Okay.
Length of both characters or both strings. I don't think we can get faster than this because we need to compare every single character uniquely for an anagram.
For you're talking about just the
Just
anagram part.
yes, just the string comparison part.
Okay.
Give me.
What if?
Sure. Go ahead.
So what if the two strings are of a different length?
Then you immediately know off the bat if it's.
Good.
Yeah, so that's a shortcut we can take. So I guess like just check length. Okay, so I'll keep that a note as a note when I write my algorithm. But worst case, it's we have to iterate through every single character. So I think that does it for the subproblem of string comparison. Now back to the array traversal. Can you give me a few minutes to think quietly? Sure, thanks. we don't care what order each of the elements are, as long as they are next to their anagrams.
Mm-hmm.
Right? Okay. I do feel like there is a linear time traversal swapping for this.
Well, there.
Mm,
So well, if you want to do a linear time traversal, then you might have to do something else as well.
mm-hmm.
Okay. I'm gonna give you a suggestion.
Sure.
So let's list out a couple of anagrams. Let's say, uh, let's list out some anagrams of ABC. Doesn't have to be all of them, just a few.
Okay. Are you still there?
I'm here, yeah.
Okay.
So let's list out a few anagrams.
Oh,
The
you're telling
reason
me to
why,
list it out. Sorry. I was waiting
yeah,
for.
the,
Okay.
the reason why I'm suggesting that is because I want you to look at these different anagrams and tell me what similarities they have or what similarities you can get with a bit of manipulation.
Okay, so this is an example. Well, these are all the ABC anagrams,
Mm-hmm.
right?
Yeah. What are some similarities? Some characteristics that
Um,
they have.
they all have the same letters.
Mm-hmm.
Well, that's given for anagram.
Yeah.
Um, I'm thinking you can like add up all the character values to get like a quick way to decide if they're anagrams. No, that's not safe though.
That's not safe.
Yeah.
Yep.
You can sort all the characters
Mm-hmm. And
to
what would
get
that
all the
give you?
same, like
Yep.
ABC.
Yep.
Um,
You're on the right track.
okay, I see. Um, So assume sorting for characters in the string using Quicksort would be so W-O log and log n. Once I sort, so let's do it for this example here. It'll be AB. Whoops. No, this is the bad. I should do it here. AB, ABC, AB, A, and then ABC. Once I sort this, I can check for equivalence right away. But I need to move it. Oh, I can sort this again, this whole thing. Instead of this time by string instead of characters. So I'll stick this whole thing into a sort. So that let's do like a quick sort twice algorithm. This, so this is for each letter, for each character in each letter we sort, and then we sort the whole thing. I don't know, n log n plus m log m. Which is much better than n squared, certainly. So that is one way to do it. Also, this way, using this method, we don't have to use this. The bottom string comparison for anagrams function. So that is, yeah, that is another way to do so.
But so can you explain to me? So when you sort the array, how do you get the intended result, which is below your cursor? So A B B A A B C C B A A.
Oh, for this, for the blue elements.
Or
well, if you can, if you do quicksort on a array of strings, it will look at. Well, I'm not sure what formula it follows, but I'm very sure it follows.
I mean, like, so you sort this array.
Oh, you mean how would the result come out to be?
Yeah, and the result.
I would say A, AB, AB, ABC, and ABC. But I see, this is not that. This is not the original problem. You could make a separate hash or a separate array to keep track of the indexes. And then just remap the original elements to its index, loop through it, and then remap it.
So you're saying okay.
Yeah, so we're saying we map this so we don't actually sort the thing itself. We map this to an array that keeps track of where each index is.
Mm-hmm.
And then
Yeah.
we make an auxiliary array of a copy of it that's actually sorted. Or sort the map, and then the map will tell you which index goes where. So we like remap it back using the original example here.
Okay. That might work.
That'll work. It's not very elegant. Let's do remap. The remapping takes n time, which is incorporated here.
So can you think of another? So okay.
Can we use
So,
complex data structures?
okay. If say if you're allowed to store, if you're allowed some extra storage, could you make it better? That's what I'm asking.
Yep. A B. If I'm allowed extra storage.
Oh, and also, you said that. So this is. I just wanted to add. You said that you didn't need the comparing string for anagram part down there, but are you sure you don't need that?
So with the quicksort, you don't.
But how does how would you? So how would you quick sort strings? So what's the runtime for comparing two strings?
M for the amount for each letter in the string.
Yep.
So this would be, yeah, so this is incorrect here.
Well, not incorrect. You just missed a little part. So we know that a quick sort on an array of numbers of integers is n log n.
Right.
But with the strings, we have an extra step.
With strings.
So okay, so here, so let's go back a bit. I asked you if there were any similarities between the anagrams and what things in common there were, and you said that you can sort them to get the same string, and I think that's the right track. So I want you to keep thinking about from there. What can you? So if I said, if you had to use extra storage, could you make it
Make it
I
easier
see.
to refer to these elements.
Yeah, yeah. I can have a hash table of linked lists Okay, I would have a hash map. So let's say I've quick sorted every single character inside a string for all strings. So I have this blue example here now. Now I iterate through each element, storing it inside a hash table. Do I need to store in a hash table? Store it inside a hash table where the key is the string, the sorted string itself. So this will be AB as the key, and for the value it would be the index. But there might be other ones down the road, so instead of storing just the hash table of key value pairs, I can store a linked list of key value pairs. So this will be a node for AB. Well, rather like this. Sorry, this is less confusing. Okay, so when I look at element 2, it'll make a new key. Store index of 2 here. AB. Sorry. This heuristic is confusing me. So let me erase it. So,
sure.
Yeah, this is bad data. So this is index 0, index 1, 2, 2, 3, 4. So, okay, so AB is 0 here. ABC is 1. 1. BA, which is AB, is now 2. This will create a new, well, it'll append it to the head, but this will be in this list. A will be by itself, which is 3, and then CBA ABC is 4, but it already exists, so I'll stick it onto this. And after you're done with the list, you go through each element in the hash table, and you can take the value index and make a new list, make a new array with the same size, and just populate it with, map it to the original. So here we would say first thing hit is, assuming this is a linked hash map, it will preserve the order that it was in. So let me just write that down.
Does the order matter?
Order does not matter, but yeah. So let's just say we're going from top down here. It'll be 0 and 2 indexes. 0 be AB, and then 2 here is BA. Next will be 1, 4. ABC. Oh, yep, and CBA.
Yes.
And the last one is 3, and it's just A by itself. And we will have done this. So the original sorting for each character would take M, let's just say M here. Rather than n log n, if n is the amount,
or maybe use different variables instead of just
m
n.
for the okay, if m is the average amount of characters in here, then this will take n words times m times n times m log m.
Or how about, let's say, express that in terms of the longest string. So let's assume
Sure.
Yeah. So
Okay, so if you're
let's say
change color here, the longest. Let's do X characters. Each sorting would be X log X.
Yep. And
then yeah. It will need to do that for each character. With n characters, so if I expand this algorithm, n times egg log x, so this is for sorting each element in here. Now, after I've sorted it, I iterate through the whole list again and stick it inside linked list. So this should, iterating this should be linear time, sticking it in here should be constant time. So linear time we already have, so we're going to condense here.
okay, yeah.
Now, after we're done doing that, we loop through everything in the hash map. So that should be linear time too. And reading it off is constant time here, so the total time, the big O of the total time is n times egg log x.
Yep. So that is, yeah, so that's good. So you have.
Okay, so.
You got it. So do you want to
implement it?
We have some time for you to implement it, or
yeah, let me just do that. I think. Is that okay?
Okay. Yeah.
Here we go. Alright. Let's hope I can take less time than the first interview. So first we have a function. Let me just do. So you want to sort an array of strings. So plug. I'm guessing you want to return this string array. Sort anagram, and inside we will get a string array input. This time I'm hoping this tab will work. Yes, okay. So first thing, so I'm just gonna make comments so I can keep track of my code better.
Sure. And if you want, you can also, you don't have to code everything.
Yeah. So I'm gonna loop through each member and create new array for sorted characters. No, damn it. Alright. So that's step 1. Step 2, once everything is sorted, loop through new card sorted array and populate hash linked list. Hash of linked list. Now once we've done that, loop through hash map, and map out arrays. Map out. We can actually reuse the array we've created for the first one to have for the final output, because we don't need those values anymore. Repopulate auxiliary array with correct indexes. Okay. So we need a new array. String array. This is, let's call this aux array. Let's just call it aux. Equals new string the 8. Is that the correct syntax? Sorry.
Y8.
Oh, sorry. You know what? Let's do this.
Okay.
Goes new data. Okay. Just taking shortcuts here. Loop reach memory create. For string s inside input, I'm just gonna take a bunch of shortcuts. Damn, this thing is really annoying. For s int what's a quick way to sort all the characters within the string? Alright, I'll figure that out in a bit. Once it's sorted, we populate that back into the array list. Okay, now we loop through in aux. Need a hash map here. Oh man. Yeah, I can see where this code would be a lot. Let's do hash map string node. So we get the node inside if map if it doesn't contain the string, we make a new string. Let's do new. And we store the index. Then I guess we need a for loop. Sorry. So let's assume the node stores the index, and we've made a constructor to just store that index. Why does it happen? Okay. New node, and then map dot add. We add the aux at I. And then we add the new node. Else, if it contains it, then we just get the node and we append to the head of the node, as we would any linked list. So node head equals map dot get the string itself, which is aux.I. Ah, damn it. Head. Let's do node. Just gonna copy this. Let's do I think there's a better way to write this.
Actually,
oh, okay.
I'm gonna suggest abstracting or using more abstraction at this point.
Okay. I see.
So yeah, like if, for example, you're saying, add to that bucket, right? Because that's essentially what it is. It's it's a bucket. So then
Let's do.
it might help you if you abstracted everything at first, and then ask the interviewer what they want you to actually implement.
Okay, that's a good point. Yeah.
They need to see you implement a linked list necessarily.
Yeah. Let's do int index. So something like that. probably add some class here so you can retain the variables. Yep, so I would stick this up here. So I'll comment this out for now.
Okay.
But we know it's there. So for here, we would just do add node to hash map. The key would be the string itself, so aux I, and x would be I, and that's it here. Now you loop through the hash map and repopulate for node and in hash map. Is there a traversal iteration, like a iterator for hash map? Is this how you do it? Map.
Well,
I think it's like for key value pair in map,
for
right?
all keys, right? Like,
yeah.
I think it's, yeah. I don't know how that is, like how to write that, so it's fine. We can just, yeah, we can check later. So
yeah.
So tell me what you want to do.
So I want to grab every key value pair. I only care about the value at this point, as long as they're in.
Okay, so for every key in the map, so for every sorted key, right?
Yeah. Okay,
Sorry,
so
not
I
sorted,
think
but every. Yeah, I know what you're saying. So.
Yeah. Actually, there's a shortcut I can take here. I don't need to store this in order. I can store the original and just literally print it because they're in the linked list already. So I think that's a better way to go because I don't have to map it back.
Okay.
So it's almost for free.
Yeah.
So I would do input here. Here, okay. Wait. Instead of storing the index, no, sorry, yeah. I still need the keys to be the same, but I can put it in the index. So our nodes would store the string itself, the original string, instead of their index. Yeah, so I think this is a much better way of doing it. Store.
There's actually, what if I said you didn't have to? Okay, well, what if I said you actually just needed a hash map? Like you don't.
I see.
Extra arrays or. Yeah. Can you think of a way to not need that extra storage?
Um, we want to utilize a hash map to detect collisions for the sorted auxiliary.
Yeah, we want to keep the hash map, but like, so in this function, you're not just creating a hash map. You're also creating
a linked list
a
inside.
new array list.
Right? Oh,
I
see.
Can you do it? So you see array list string aux, right?
Right.
Can you do it without that?
I think I can. So once the characters are sorted.
So actually, let's go back. So for each string in the input array, what do you do? What are you doing for each string? Tell me again.
I am sorting the characters inside each string, so they are in alphabetical order. After that, I'm putting it in the array. Can I put that in the hash map directly?
Why not? And what would you need? What information would you need to put that in the hash map? So here,
if it's already sorted.
Here I'm gonna. So here, I think we can just add a function that we will implement later or not, but we can say sort string. So let's call that sort string. Let's find something. So now you have. Yeah. So just
okay.
So it's clear. It's like, I think the comments, you weren't really looking at the comments.
Oh, so yeah, yeah. If I stored the sorted string in a hash map, the moment. So I haven't populated it. I haven't populated anything yet. So it'll store here. It'll store AB, and it'll store ABC. On BA, it will collide with AB. And then we stick it in the, so we still have that linked list functionality. Yep. We just kind of integrated that, into without the array list in the beginning. Okay, yeah, I see where you're getting at. Would you like me to change my code to match the optimized algorithm?
Hold on. So.
Okay, here we go.
It doesn't matter, but yeah, so.
Yeah, so we can take out. So once it's sorted, we will add the node. So this will need to be a for loop. input dot length. So I need to sort that. So the sorted S would be sorted as here, be the key, and then we stick it to some hash map inside the linked list.
Okay. Yes. And
okay, so that gets rid of this, that whole middle chunk. Okay, I think I remember how this goes. Key value pair. So this is a string. Pair inside map. Now that we have everything, pair dot value. So this will return a node. Let's make this a little bit simpler. Node head equals pair dot value.
Or actually, I'd like you to, if it makes it easier, why you can abstract the linked list class. Oh, you don't have to. I mean, you don't have to type in the code for it yet. Maybe. Yeah.
Oh yeah.
Just
yeah.
like. Yeah.
Okay. Oh, just on here.
Yeah.
Got it.
It's like how I did the sort string thing.
Yep. Let me figure out the best way to do it.
If it makes it easier. If it doesn't, then just go with what you were doing.
Yep. So I'm thinking we can just rewrite the input string array because we don't need it anymore.
Yes.
Input okay. How do I clear an input string? Do you know how to clear an array? So my thing is, my strategy
Clear
is
an array.
Yeah.
Why do you? So, so you want to clear the array
Okay.
and then what you want to do?
Okay, now I think I got it. Just trying to do a workaround. Alright. I'm just gonna abstract this out. Just stick the array in here. And this overwrite array function will keep track of what index it is at.
Okay.
So so start at 0, and then it will populate. Once it populates a pair value in the list, it'll just keep incrementing.
Okay.
So that is,
I think you have the
gist.
right idea. So.
And then you return input once it's done.
Okay. So
all right.
Should we debrief then?
Let me check the space complexity for this first.
Okay.
So we said time is n log x. I don't think that has changed. This is log x.
And x log x, right?
X log x, sorry. For the space though, we need a hash map. Each hash map. Okay, so either you create a new index with a node, or you have an index and then you just append to the linked list. So the space complexity, worst case, would be linear. Alright, that is my answer.
Okay, so yeah.
How long did that take?
You got it.
A little bit too long.
let's check later. But
okay.
So let's see where to start. So for the overwrite array, like when you return, but right before you return to the array, you're taking in you're looping through the hash map and taking each thing you see and putting it in the array. Do you have to do an extra method saying overwrite array? Like, because so this is where I'm unsure, because in an array of strings, when you replace an element, doesn't the other just get dealt with by garbage collection?
Yes.
So you don't have to actually remove it. You just assign it something else.
Yes. So what I was trying to do there was, I was trying to append to the end. So if this was an array list, if my input was an array list, I can just throw it out and garbage collect, and then just do array list equals new array list, and then append to the end. Since we don't know the length of the pair, the node list in the pair here, we have to keep track of an index on a outside context. So I resolved that by keeping track of the index here. Does that make sense?
Also, I think, well, yes, but I think a simpler way of looking at it would be, you know that there are n strings, right?
Yep.
So you didn't need an array list, you just needed an array. Because so
how would you write this function inside? Are you talking about this function here inside?
Yeah, I wasn't sure like why. So at first, because you said you wanted to remove some strings from the original array, so that's what.
Oh yeah, I was trying to use the append function without the keeping track of the index outside, and that was the only way I can do it, that I can think of. Yeah.
Okay.
Yeah.
All right. So let's see. Yeah. Okay. So my comments were. So when you started, I think. Let's see. So I wasn't. I felt that you weren't really comfortable with the run times sometimes. So like the big O at times.
Yep.
Like you still got the right answer, but then it didn't come to you immediately. So that was, I think, something that you can work on.
I have a
You can,
question for
well,
that.
yeah,
Now that we're on it, so we have n, which is the number of members, right?
yeah.
When we need to actually go down into each character, should we always assume the longest string in a character,
It makes it
right?
easier. Yeah,
Okay,
yeah.
because here I was doing like, oh, what if I like did an average, and that was like not. I don't think that was helpful. So yeah,
Yeah,
let me write
if
that
you
down.
because if you remember ON is the upper bound, so
Right.
it's so you just need to if
Let's,
the actual result is less than that, then that's fine.
right. Okay.
There is a chapter in the book uh, before the problems, and it talks about it gives you a lot of examples of
Okay.
ON, like O time, and that's very helpful for me anyway. So you did well in the beginning. You separated the problem into two parts, which is, well, at that time it was sorting, was comparing, like, so sorting the string itself, and also uh, comparing two strings to see whether they're anagrams. So that was good. But at the same time, when you were doing the code, uh, I thought you could have used more abstraction and more
Okay.
uh, modularization.
Yeah.
So it's okay to just assume you have methods written already and just say, oh, I'm gonna use this method which does so and so, such and such,
Yep.
and then uh, the interviewer might be okay with that.
Yeah.
So
But it
that will
saves me a
save
lot of
time.
time.
And
Yeah.
if not, then they will tell you to implement it. But then it's so easier to follow anyway.
Yep. Okay.
So I think what would help you is you do everything. You might be able to do everything from the top down. So and then fill in the details if that makes any sense.
Yeah.
Like for this example here, you're sorting all the characters in the string, sorting each. So for each string, you're sorting it, and then you're adding it to the bucket, right? And then once you're done, you're going through the bucket, and then sticking each thing in the bucket back into the input. So here, if you've abstracted a lot of the stuff, which makes it much easier to follow, and then you can fill in the details later.
Okay.
Or whatever they. And then, I mean, same thing for the linked list.
Yeah.
So
yeah.
abstract as much as you can. That will help.
Okay.
So I think that's it.
Got it. So if you were actually interviewing, let's do like value.
Oh,
you wouldn't. If you were interviewing, would you expect people to actually implement this? The abstractions? I guess like depends on how much time we have left.
Yeah, I think if they were able to get like a solution fairly early on, then I might ask them to keep trying for a better solution.
Yeah.
Otherwise, I would just ask them to implement the less efficient one. But I would definitely want to see abstraction. And
Okay.
then if there was time, I might ask them to implement one of the methods, the abstracted methods. But if not, I still want to see if they have if they're able to translate what they walked through in the example into code.
Got it.
Even if it's just abstracted.
Okay.
Yep.
Got it. Okay, so it turned out at least this comparison string was like a red herring for the optimal solution. The red portion here, the comparing strings for anagram.
Yeah. Mm-hmm.
Okay.
But that is a
it's
necessary part for you to
right.
For your other solution though.
Right. Okay. Okay. Cool. Yeah, I think that wraps it up for me.
Okay. Yeah, I'm not. I think that's it for me too.
All right. Sweet. Thanks for watching, everybody.
Thanks for tuning in, everyone. See you next time.
Yep. See ya.